So hello everyone. Now today's topic that we are going to take is your moment of inertia, right? That topic is defined as your moment of inertia. This topic is very much relevant, or you can say very much important with respect to the strength of material, or you can say the design portions of mechanical engineering, right? So moment of inertia को अगर हम define करें तो it should uh, it is to be defined as I equals to mr square, right? So जब भी moment of inertia in terms of mass defined होगा, then it is known as your mass moment of inertia. Suppose if your moment of inertia is defined as in terms of area, that is pi d4 by 64. If this term is written, it means it is defined as your area moment of inertia, right? So moment of inertia is being defined with respect to the mass moment of inertia and area moment of inertia, right? Okay. Now, based on this condition, now I'm going to write some of the important parameters. Let's admit everyone. And this, now everyone can join this. Okay. So the parameters, I'll start. I'm just writing this term in this condition. Let us start with the parameters. Parameters of defined as your first moment, and we all know that moment of inertia is your always your second moment, right? So let's take an example of f, that is your force. So force into radius, so or it is defined as your bending moment. When you multiply by force with radius, it is defined as a bending moment, or force into radius is also gives you torque, right? So the second moment is defined as your F into R into R, F into R into R, right? Okay. So when you multiply force into radius, it gives you either bending moment or torque. Further multiply by of radius gives you a second moment. So it means it should be written as F cross R, right? So similarly, when the parameter in terms of mass, right? So we can write M into R, and its second moment should be written as M R square, right? अब एम आर स्क्वायर का सिग्निफिकेंस को अगर रिस्पेक्ट में जानने की कोशिश करो, then एम आर is meaning you can say that it is a resistance, it is a resistance to rotation, right? Or you can say that it forms the basis of a rigid body dynamics. Mr square, it also defines like it forms the basis, it forms the basis of rigid body dynamics. Okay. Now, when we're talking about area, right? When we're talking about area, so we can multiply it by A cross R, and the second moment is defined as A R square, right? So AR square is represent like MR square is a resistance to rotation. Similarly, A into R square is defined as resistance to bending, right? Resistance to bending. अब इसका मतलब क्या होता है? अगर हम यहाँ पे देखेंगे, if any body is a form of, अगर MR square को आप एनालाइज करो, तो it is defined as a resistance to rotation. ठीक है? The second moment of mass moment of inertia को define जब करते हैं, तो इसका मतलब है it always resists to rotate any body. When the things in a rotation, it comes under dynamics conditions, right? Similarly, when the things, it is defined as a resistance to bending, and if it is defined as a resistance to bending, it means that we can say that and forms the basis of the strength of material. Strength of material, right? So always remember one thing: when you have anything which is resistance to bending, then you have your area moment of inertia, right? When you have anything which is resistance to in a dynamic condition, then you have your mass moment of inertia, right? So based on this condition, now I'm going to define one thing. Like suppose I'm going to, if you have x and y axis, this is your x and this is your y axis, and in this x to y axis there is a body which is to be defined in this condition, right? So we can say that suppose this body, its center lie at this particular point. So this is defined. So the center is defined from this axis as x, y, and this point is defined as x, y. And suppose a small area of this particular is defined as dy, right? So with respect to your area moment of inertia, if I'm going to write it as an area moment of inertia, right? So when we're talking about the area moment of inertia, it could be written as if it is with respect to, अगर हम ये x axis के respect जानना चाहें कि इसका moment of inertia क्या है, then x axis is to be defined as your y square d a, and similarly your y axis, about y axis, it should be your x square with small d, right? So based on this equation, let's define some of the shapes, right? So suppose we have first a rectangular area, right? Okay, let's draw a rectangle. Then in this, suppose we have cut a small area, and this is of your x-axis. This is, suppose it is defined as your x-axis. So about x-axis, this is the distance. We can say this is your y distance. We can say it is defined as your dy. This is, you can say, the height of this rectangle. And this one is defined as your width of rectangle, right? Okay. Now you can see in this criteria, you have to find out your moment of inertia about x-axis. If it is about x-axis, can I write this equation I xx is equals to the integration. If I take an integration from this point to this point, right? So here we can define as a 2 twice, because यहाँ से यहाँ तक और दोनों की sides को लेना ना, and both are of mirror image to each other. So if you define in this way, तो आपका value of integration क्या होगा? 0 to h by 2, right? Okay. Now this is your y square. So we can write the value of y square into. Just tell me, this is dA, that is area. तो ये area क्या होगा? B into dy. So we can write here that is B into dy, right? So if you are going to integrate this values to I x axis, that is your moment of inertia about I x axis should be written as B h cube by 12, right? So आप हमेशा याद रखना कि अगर आप विद रिस्पेक्ट टू सेंटर फाइंड आउट करने की कोशिश कर रहे हो, तो इसका मोमेंट ऑफ इनर्शिया क्या होगा? बी एच क्यू बाय 12, राइट? सिमिलरली अगर आप इस कंडीशन पे कैलकुलेट करना चाहते हैं कि चलो वी नीड टू फाइंड आउट द वैल्यू ऑफ about y axis, this moment of inertia about y axis, so we can write this values of y, राइट? अब इसके रिस्पेक्ट में आपको यहाँ पे कहीं कोई एरिया कट करना पड़ता और आपको यहाँ पे डिफाइन करना पड़ता, तो दिस इज द वैल्यूज ऑफ x हियर इन दिस केस, वी कैन से दिस इज योर dx एंड दिस इज योर h. तो आपकी इक्वेशन क्या बनती? 2 0 to b by 2, this is your x square, this is your h into dx. So when you are going to solve this equation, you will get b h b cube by 12, right? So always remember one thing. So when you are taking जिस axis के about आप लोगे, उस axis का जो length होगा वो h cube के part या cube के part को represent करेगा, right? So this is the rectangular area, or you can say this one is the area of this rectangle, और आपने यहाँ पे calculate कर दिया कि what is the moment of inertia about x-axis and what is the moment of inertia about y-axis. Is it clear to everyone? Now let's solve the another one, that is your square area, right? If I say of a square area, so I believe it is to be very clear to everyone. This is A, this one is also A, right? So about x-axis, if you are going to find out the moment of inertia about x-axis, so either it should be of x-axis or it should be of y-axis. So you can write that this is A into A cube by 12, right? So this can be written as A to the power by 12, right? Always remember one thing, like this is one of the important things I believe you should know. If this is the case, right, and you have to calculate the moment of inertia about this one also, right? And this about this axis, about moment of inertia about x is also same about the, जैसा कि आपका एक सिंपल इस कंडीशंस के टर्म में डिफाइन किया, right? Okay. Can anyone tell me the next term how we are going to find this moment of inertia? Let's draw a moment of inertia of hollow rectangular section. Can anyone calculate this area? Can anyone calculate what could be the moment of inertia of hollow rectangular about x axis? क्या कोई कैलकुलेट कर सकता है? Just tell me. This is your width. This your width. Similarly, that is your capital H, and this is your class. Just tell me, फटाफट. This is to everyone. Please tell me what is the moment of inertia of this hollow rectangular section about x axis. You should be quick to answer this question. This is very easy. Aditya, please tell me. Aniruddha, tell me this answer. This is very, very easy and very simple. I believe I am audible to everyone. Yes? Omkar?
Sir, capital BH cube by 12 minus small BH cube by 12.
Exactly. Capital BH cube by 12 minus BH cube by 12. This is very easy and आप फटाक से आंसर इसका कर सकते हो. ठीक है? So moving to the next part. I know this topic is easy to everyone, but still it is important. Let's find the I section, right? So if I'm going to draw an I section, in this I section, this is your B values, this is a small b, this is small h, right? And this one is your h. So you need to find the moment of inertia x-axis, right? About this x-axis, please. Prashant, just tell me. ये भी B है, ये H है, ये B है. This is also B. This is also H. This one is also very easy. So similarity conditions को अगर आप देखोगे, so we can define that. चलो let's draw this. Right? So अगर आप सबसे पहले अगर आप देखोगे, तो it is a simple rectangular condition. This complete red dot is like complete rectangle condition. तो हमने क्या किया, I x axis को पहले calculate किया, and this consider the capital B, so we can write B H Q by 12, right? This is the complete structure or rectangle of this one. Minus, you need to eliminate these parts, right? So each one is considered as a rectangle. So B H cube is one thing, और दोनों equal है, so that is defined as 2 B H cube by 12. So this is a case of I section moment of inertia, right? Okay. चलो नेक्स्ट कंडीशन हम पढ़ने जा रहे हैं, that is your parallel axis theorem, right? So let's understand what is parallel axis theorem. The next criteria, this is your parallel axis theorem. right? For this, let's first draw this. Let's draw a rectangle, right? So suppose in a simple condition, if I'm going to calculate a moment of inertia of this rectangle about this x-axis, so this is a value of y from this axis. Suppose this is the height, small h, and this one is your area d, right? And this is the width of this one. So how you're going to find the value of this one? So as per the normal condition, I x-axis can be defined as this value is from 0 to h. 0 to h y square into dA. So that area is your, this one is your shaded area. That is B into D1, right? So this can be written in here in this case, that is y cube by 3. That can be written as B y cube by 3, which is also to be defined as a B h cube by 3. So it means what? Means what? Your axis, your moment of inertia at the end, or you can say at the extreme of your rectangle is bh cube by 12, right? So you can also find this moment of inertia with the help of parallel axis theorem. So what this equation says, if I'm going to find out this with the help of parallel axis theorem, we can say that by parallel axis theorem, we can define that I is equals to I, that is moment of inertia about its center, plus area into d square, right? So how this is going to be utilized? D square, it means what? Your distance measured from its center, right? चलो यहाँ पे ड्रॉ करते हैं फर्स्ट एक रेक्टेंगल हमने ड्रॉ किया और उसके सेंटर से एक वैल्यूज को, दिस इज डिफाइंड एज योर CG, right? And you need to find out the moment of inertia about this axis. So here we can say the x, and here we can say the x dash. Right? The value of center from this x dash is h by 2, right? So how, what is, let us first understand the moment of inertia about its center. We all know that it is defined as b h cube by 12 plus area. What is the rectangle area? That is defined as b into h. This is your b, this is your h. So we can say that b into h, and d square is a distance. So distance is h by 2. So we can write here h by 2 of square, right? So when you are going to solve this, you will get b h cube by 3 by x dash, right? So you also understand if these two axes are parallel to each other, so that we can apply parallel axis theorem in this particular condition. So as per the parallel axis theorem, you can calculate the moment of inertia at the extremes of this rectangular, right? Right. Now there is another method which can be see here, that is perpendicular axis theorem. One is your defined as your parallel axis theorem, and another condition is defined as your perpendicular axis theorem. So let's understand, or let's see what is perpendicular axis theorem. This is your perpendicular axis theorem, right? So let's take up the same example. So this is your rectangle. So in this we have two axes, right? One, it is defined as x-axis. This is of height h, and this one is your width b, right? So if I say x-axis, right? So then it's defined as bh cube by 2. Similarly, if I say y-axis, it is to be defined as h b cube by 12, right? So there is one more axis which is perpendicular to this axis, which is defined as z, right? So if I say what is the moment of inertia about this z axis, then it should be as per the perpendicular conditions. It should be because z axis is perpendicular to x axis and also y axis, right? So we can write that I x axis plus I of y axis about the centroid, right? So here we can define as I x axis by y axis यानी कि b h cube by 12 plus h b cube by 12, right? And this about z axis को ही हम polar moment of inertia बोलते हैं, polar moment of inertia, right? So let's understand in a very simple कि आपको जो है एक सर्कुलर एरिया हम कैलकुलेट करना चाहें, सर्कुलर, राइट? सर्कुलर एरिया के बेसिस पे हमने क्या किया, एक सर्किल को ड्रॉ किया, ठीक है? So we can say that देखो, this is your x axis, this one is your y axis. तो एक जो इस सेंटर से पास होते हुए जाएगा और इसके परपेंडिकुलर होगा वही z एक्सिस होगा, राइट? So if how you are going to find this moment of inertia about x and about y axis को अगर हम कैलकुलेट करना तो हम एक काम करते हैं कि let's cut an elemental ring here, right? Let's cut an elemental ring which is defined as R, right? And this is defined as your dr, right? One thing it is very you can say clear that whatever the moment of inertia about x-axis, that is will be same about y-axis, right? So if you are going to find the moment of inertia about z-axis, so it should be ixx plus iyy, right? So you can also that it should be either ixs twice of or it is also twice of iyy, right? So this ijj can also be written as j, that is a polar moment of inertia, right? Now this can be written as 0 to r. Now this is r square into area. तो एरिया क्या हो जाएगा आपका, ये 2 pi r into d r, right? So this can be defined as j. Now it is to be further solved that j is equals to you can say 2 pi r क्यूब है तो यहाँ पे हो जाएगा आपका r 4 by 4, the value of 0 to capital R, let's say, right? Then j is to be defined as pi r to the power 4 by 2. So this is the polar moment of inertia about z axis. or in terms of diameter, this should be written as pi d to the power 4 by 32. Is that clear to everyone? Now, if you are going to find out this is about x-axis or about y-axis, right? So it should be j by 2. It means कि आपका यही जो वैल्यूज है जो आप पाई डी स्क्वायर बाय 32 लिख रहे थे, तो ये 32 into 2 हो जाएगा, which is to be defined as pi d square pi d to the power 4 by 64. So I believe this point is very clear to everyone why this polar moment of inertia is defined as a j d to the power 4 by 32, and about x-axis, or you can say about y-axis, it should be of pi d to the power 4 by 64. Aditya?
Sir.
Yes, you asked one time, right?
Sir.
So I want everyone to solve this question. Please solve this question, this one. Class, can you please solve this question? This is of diameter of, you can say, 50 mm. This one diameter is of 100 mm, right? X dash, right? So this is the center of gravity of this one. ये hollow section है, condition है. Please tell me what is the moment of inertia about this axis, capital X axis. Please solve. So class, let's see this question, how we are going to proceed this one. So in this question, you can see that this is a circular disc, or in this circular disc, there is a circular hole in this pattern, right? How we are going to find the moment of inertia of this particular diagram about this capital X axis, right? So we need to first find out the moment of inertia about this small ring or small circle. तो अगर हम इसका मोमेंट ऑफ इनर्शिया अबाउट द सेंटर कैलकुलेट करने की कोशिश करें अबाउट x dash axis के अबाउट, then it should be pi d to the power 4 by 64, right? But the problem is कि अगर इस डिस्क का मोमेंट ऑफ इनर्शिया देखो तो ये अबाउट इट सेंटर है, राइट? तो हमको पहला तो मोमेंट ऑफ इनर्शिया इस पर्टिकुलर डिस्क का अबाउट कैपिटल x के रिस्पेक्ट में कैलकुलेट करना है. तो हमने क्या किया कि यहाँ पे पैरेलल एक्सिस थ्योरम के बेसिस पे स्मॉल सर्कुलर रिंग का कैलकुलेट किया मोमेंट ऑफ इनर्शिया. तो स्मॉल सर्किल की कंडीशन जो है पैरेलल एक्सिस थ्योरम के बेसिस पे we can find about x axis can be written as I x dash dash plus area into d square, right? तो एरिया क्या है यहाँ पे, ये है आपका d by 2. this area can be defined as d by 2. so this can be written as pi d to the power 4 by 64 plus what is the area? Area can be defined as pi r square, right? So in terms of diameter, can be written as pi d square by 4, right? And d जो distance है यहाँ पे, it's not a diameter, distance d is defined, so that is defined as d by 2, right? So this is the moment of inertia of a smaller circle about x axis, right? Now with respect to that, अगर हम सिर्फ अगर एक big circle moment of inertia इस पूरे diagram का calculate करने की कोशिश करें, so we can define that this is the pi d by 4 to the power 64, about 64. ये होगी total circle का moment of inertia minus of this value, that is pi d to the power 4 by 64 plus pi d cube by 8, right? तो d square है ना, तो ये जाएगा d to the power 4, right? तो ये जाएगा pi d to the power 4 और 4 और 4 16, yes. So this is the moment of inertia of this diagram about x-axis. So as Omkar said, its answer is 3.37 into 10 to the power 6 mm to the power 4, right? Okay. Now there is an important thing. If I say a circular ring, if I say a circular ring, you all know the moment of inertia of a circular disk, that is pi d to the power 4 by 64 about x-axis or about y-axis. And similarly, if it is a polar moment of inertia, then it should be pi d to the power 4 upon 32. But if I say a circular ring, so what is the significance or definition of circular ring? Let's first understand. If I say a circular ring, it means that it is a ring of very less thickness, right? So if any where it is to be mentioned of circular ring, right? It means what? The thickness is very less, and it is at radius r, right? तो ओके, अब हम इसके पोलर मोमेंट ऑफ इनर्शिया को कैलकुलेट करने की कोशिश करते हैं जे. तो जे कैलकुलेट कैसे करेंगे? दैट आर स्क्वायर, ऑलवेज रिमेंबर वन थिंग, दैट इज आर स्क्वायर जो आपका डिस्टेंस था इनटू एरिया. एरिया कितना था? 2 पाई आर इनटू टी, राइट? So this will be your 2 pi r cube into t will be your polar moment of inertia. Class, always remember, right? And if you want to find out it with respect to ixx or iyy, so then it should be j by 2, which can be defined as pi r cube into, right? अगर कोई क्वेश्चन में सर्कुलर रिंग और थिन सेक्शन मेंशन है तभी ये फॉर्मूला लगा सकते हैं, अदरवाइज जो आपने पहले पढ़ा हुआ है वो आप वहां पे यूज करोगे. Is that clear to everyone? If you have a circular ring, your polar moment of inertia is 2 pi r cube into t, and your moment of inertia about x or y axis, it should be pi r cube by. Is that clear to everyone? Okay.
सर एक डाउट है.
Next.
हेलो.
Okay. Now we are going to see a triangular section. Triangular section, right? Let's draw this triangular section. And we need to find this moment of inertia of this about x-axis. This is the height of this triangular section, and you can say this is the width of this triangular section, right? So always remember one thing when you're going to solve this about this axis, and this is about center, about the center. This नीचे से pass कर रहा है. Its value should be BH by 36, right? Similarly, if I am going to solve this with respect to the extreme end, so I believe this यहाँ पे polar moment of inertia से आप calculate कर सकते हो. So then it's sorry, polar moment of inertia, parallel axis. I x-axis can be defined as BH by, right? This is one of the important thing you always remember. And now there is a one discussion which is also to be required on radius of gyrations, right? So what is radius of gyration? Radius of gyration is defined as your whole body weight should lie on this particular center, which is you can say apart from k distance from the axis. So that area A, suppose उसका area जो है वो pi by 4d square, that is center of the area, it is to be defined in this case. So then its moment of inertia, right? कोई भी random condition है, random body का हमने बोला कि उसका center जो है वो किसी k distance पे lie कर रहा है, तो वो k जो है that is defined as a radius of gyration. So its your moment of inertia about this axis can be defined as a k square. A area can be of anything. It means what? The value of k can also be defined as under root I x-axis about a, right? Okay. अब एक सर्किल है, if it is a circle, तो moment of inertia about this I x क्या हो जाएगा? Pi d to the power 4 by 64 अपॉन एरिया. यहाँ पे आपने क्या कैलकुलेट किया? Pi d square by 4, right? It means what? In that case, your radius of gyration is your d by 4, right? So that is of x-axis के respect में अगर हम बात करें. Similarly, अगर हम k of y-axis के respect में बात करेंगे, तो ये होगा I y about a, right? और its values will remain same, that is d by 4, क्योंकि एरिया के respect में बात कर रहे हैं. Class, is that clear to everyone what is radius of gyration and how it is to be utilized in this condition?